Welcome. In this final example, we're going to integrate tangent squared x times secant x dx. Now let's recall our two cases for integrating tangent and secant. So we usually look for one of two things. We either look for secant raised to an even power, which we don't have. Secant is raised to an odd power. Or we look for tangent raised to an odd power. Again, we don't have that because tangent is raised to an even power. So to tackle this one, let's rewrite it. That is, recall that since 1 plus tangent squared x equals secant squared x, it follows that tangent squared x is equal to secant squared x minus 1. So rewriting, we end up with secant squared x minus 1 times secant x dx. And this is equal to secant cubed x minus secant x dx. And now, if you've watched my other videos, you've seen the integrals of both of these. That is, you've seen what both of these integrate to. So let me split this up into two really quickly. This is the integral of secant cubed x dx minus the integral of secant x dx. And from my previous video, the integral of secant cubed x dx is equal to secant x plus tangent x plus the natural log of secant x plus tangent x divided by 2 plus a constant c. And the integral of secant x dx is equal to the natural log of secant x plus tangent x plus a constant c. So let's go ahead and replace these. That is, replace secant cubed with this, and this integral of secant with this, and you have secant x plus tangent x divided by 2. And since I'm running out of space, I'm going to add this last term here, that's plus the natural log of secant x plus tangent x. Oh, no 2 here, excuse me. And this is plus a constant c. Oh, before I continue, this should be a negative. So in our final step, we're writing secant x plus tangent x over 2. That is not changed. And then we have minus the natural log of secant x plus tangent x divided by 2 plus a constant. So again, this indefinite integral evaluates to this right here. I hope this video was helpful.